Hey there! I've got a little something here that I made up for Pi Day, and I hope you like it. As you can see, if you notice the wall behind me, yep, I'm still on location in a hotel room in Houston while my husband is out doing the work thing. And so I'm here doing the math thing, and it's awesome. I think I got the best end of that deal. But anyway, let's jump into some math. So it's Pi Day, so I had to do something with pi. So I used the fact that the circumference of a circle is 2 times pi times the radius to say, okay, pi is halfway around that circle. And so I marked that arc with its value in GeoGebra, and you can see that there. You can also see here what I used to build that if you want to build this on your own to play with. It's not a big deal at the moment for what I'm about to show you, but it's all there if you want it. Okay, so I'm going to use this slider to sort of unwrap that side of that. Okay, and as you can see, it's rounding off differently in some places than others. But that lets us take a look at what's going on here. Let's see, do I have a zoom tool? I do not. Okay, no problem. I'll just use the zoom button that's built in and come back here. Okay, now you probably already know that pi is 3.14159 blah blah, etc. But here we can see why it really needs to be. So you'll notice that this doesn't quite straighten out. It's still an arc. So I'm going to increase this number somewhat, some more, to try and make it possible to straighten that out better. So instead of a maximum of 100, I'm going to try 1,000. So I'm straightening it out more and more and more. And this dot is getting closer and closer to the line there. So we see that that needs to be somewhere between 3 and 3.2. And in fact, between 3.1 and 3.2, but now we're zooming in so close that we're able to see that that's not quite on the axis after all. Whoops, misclick. I see that it's a bit less even than 3.15. So I'm coming back here to the settings and saying, okay, we tried 1,000, that wasn't enough, let's try 10,000. So let's unwrap that more and more, and that's getting down closer. Okay, so now let's zoom in. And I see that it's a bit more than 3.14. Whoops. And it seems to be a bit less than 3.142. So let's come back here and adjust these settings again. Well, 10,000 didn't work. And as you can see, we're dealing with what's going to be a limit situation here. At some point, we're just going to have to say, okay, this is enough digits, we're stopping now. But let's not stop yet. So we can go out to 100,000 and adjust that down. And now we can zoom in again. So let's take a look at this. Whoops, wrong button. Let's see. Okay. Oh, look, there's 3.1415, and it keeps going. Okay. Well, that's 3.1416. That looks really close. Now, again, this isn't exactly straight down onto our ruler, so we could try again getting some more, straightening it out a bit further. So let's try 1 million. So it looks like it's a bit less than 3.1416. And let's zoom in to see. Uh-oh. Something just disappeared. Well, it looks like we may have found a limit, folks, to what GeoGebra can cope with. So apparently out here in the, let's see, 100,000th, out here in the Y values in the 100,000ths, GeoGebra doesn't always quite cope correctly. So let's see what we can do about that. Let's see. If I show the value of that, and with quite a lot of decimal places, we can see that that's still not quite right on the line. So we can zoom in a little further, and that exposes clearly that that point is not quite right on the line. So the arc, if it were still visible, would be still somewhat curved. And so we would say, okay, let's flatten it out a little bit more. So let's come to our input slider. Okay, so we had 1 million here. We could try 10 million and see how much closer we can get this point to the y-axis that way. Oh, it's even closer. And we can even go ahead and do 100 million. And let's see. So now we can, well, a little bit of spoilers here. We're going to have 3.14159, and I don't remember right off how many more of these digits are accurate, but you can see from this that we have, the closer we get this y coordinate to 0, the closer this x coordinate here gets to pi, indicating that the length of that arc that we can't see anymore because GeoGebra can't cope is very, very, is showing us pi very accurately. Which again is no surprise if you look at how this was constructed. Now let's zoom back out to where we can see that arc again. Come on, that's got to be showing up sometime. And of course the trouble here is that that's going in such big steps, it's hard to see. So from this perspective, it's very large values again. But if we zoom back out, now that's showing its length calculation. And we can demonstrate wrapping that back up. Oops. So once again, we can see that that does in fact show pi, even though it's hard to see the steps when we have when we're using such large numbers in our slider. So we can change that back. Let's change it back to just 1,000 to show how, okay, we were out here, and then we can roll it back up. And it pops back into place. So that is a way that you can investigate what pi really looks like and why over here between 3.1 and 3.2 is a good value for it. Now, one thing you might notice if you've taken some calculus is that we were using the idea of a limit here. We were saying that, okay, as this circle that we used to help draw that arc has a radius approaching infinity, meaning with very large numbers punched in, this arc here that was set up to have a particular length because of how that angle there in the middle was defined. So that arc that was set up to have a particular length of pi, well, its endpoint here has a y-coordinate approaching 0 and an x-coordinate approaching pi. Now, if you don't know what I'm saying here with limits, well, that's a reason to jump in and take calculus, so check out the offer on that that's going on. Oh, and something's going on now that I've got to check out. So again, happy Pi Day and have a nice time.